Welcome. My name is Luis Servin, and today I would like to share to you something I call hacking threat modeling, which means making threat modeling work for you and your company. So let me see, where's my mouse? There's my mouse. So who am I? I was a software developer. I still develop software, but I'm more into security now. So I spent the first decade of this century, 2000 to 2010, more or less, developing software professionally. Then I turned to a security consultant, started doing threat analysis, because threat modeling was not even a term back then, or not really. And then I got into an automotive OEM in Stuttgart, in Germany, and I was tasked with introducing threat modeling into the software development lifecycle of said company. It was quite an interesting challenge, which I had the privilege of working with and developing for over 8.5 years. And I helped create with my team a worldwide community of information security architects. Along the way, over these 8 years, we faced a series of challenges. And I would like to talk a little bit on those challenges and how we solved some of them, because I think these are some of the less talked aspects of threat modeling. If you have any questions, please make sure to write into the chat or raise your hand or just interrupt me. I have two screens, so on the left screen I have the chat window open in case anyone is chatting there. Okay. Let me open the chat window just in case anyone makes any question over there. Again, why did the recording? Okay, recording in progress. So while I was doing threat modeling and creating this community of practice of information security architects, I found that it was very difficult to get started. I found that we had to iterate several times on the training, the length of the training, the number of training units that we gave, so we and how often we had to train our colleagues, the methodology, we had to at least iterate a couple of times in that. And the last thing we had to iterate was the documentation. How do we document a threat model? How do we make sure that compliance people are happy with it, that developers are happy with it, that system owners are happy with it? So those are some of the challenges we faced in this company. So before I deep dive into all of this, so threat modeling, what do we mean with that, and how to make it work for you and your company? And I think that the key message, if you stop watching after 1 minute, is there is more than one way to do it. Don't limit people to doing it in one way. It's very hard because not everyone thinks the same way. So Stride has become almost synonymous with threat modeling, but quoting Shakespeare, a rose by any other name would smell as sweet. So whether we call it threat modeling, whether Stride is threat modeling or something else, I'm not completely sure, to be honest. Stride is, of course, famous because it was used at Microsoft. So if you have ever seen this book or heard of it, it's quite old, 2006. That has a couple of chapters dedicated exclusively to threat modeling and Stride. And then Shostak, of course, came out 2014. And that was fantastic because now there was a book exclusively dedicated to threat modeling, and that was a great place to start. But there are many more methods for threat modeling. And I mean, I've gone through many of them and I've read through many of them. And to be honest, the two I find the most useful because of how they are built and because they make the most sense for me coming from a developer background are the architectural risk analysis from Karen McCrow and architecture, threats, attack surface, and mitigations, with this very difficult to pronounce acronym, ATASM, from Brooke Schoenfeld. So in case you're looking for an alternative for Stride, or at least a different way of looking at threat modeling, I would recommend you to go to these references. They're quite good. I think this is nothing new, but just in case, threat modeling, regardless of the method, will usually be made up of these 3-4 steps. So you model the system, you figure out what it is that you're trying to find vulnerabilities in. You figure out the scope of the analysis. You figure out what it is really, and whether you and the developers and the system owners all understand the same thing from this system model. And then you go into the most fun part, at least for me, which is the threat elicitation, the analysis phase. So in this model, how can I attack the model, and how can I make the attacks credible? How can I make the attacks good enough that they actually apply to whatever it is that I model? And then the not so fun part, but actually the part that is the most useful, because we threat model not to find threats, but to find mitigations. And this is where we try to avoid, reduce, accept, etc., any of the risks. And then we validate the outcome and see whether everyone is agreeing on all of these items. So far, so good. And yeah, well, in the analysis phase, you can use any method, Stride, Linden, etc. So as I mentioned before, there are quite a few of them. So you could be using attack trees, you could be using Octave, you could be using Trike, and I don't know, there are so many methods. But sometimes it makes sense to take a look at threat modeling within the context of risk management. So within the context of risk management, it's sometimes not clear what we're trying to do. Are we saying that a threat agent, a threat actor, a bad person increases the risk of the system just by existing? Or do we actually mean that a threat actor using a threat scenario to exploit a vulnerability is increasing the risk? I am a fan of the latter, not the former, so I don't see the existence of the Mossad or the NSA or a bunch of bored 14-year-olds particularly as a threat. Of course, each one of these has limitations, capabilities, motivations. But it is only when we can close the circuit. Just imagine the light switch in your house, right? You turn on the light and there is electrical current flowing from the negative to the positive pole, right? That's how it works. So if you have a threat scenario but no vulnerability, so if I'm trying to do SQL injection but I don't have any SQL database behind the thing, do I have a risk? No, you don't, right? If I have an asset that does not exhibit a vulnerability, I don't have a risk because it cannot be exploited with this threat scenario. It can be exploited with different threat scenarios, but not with this threat scenario. And that's why I'm not a great fan of using some method that just focus too much on the threat and the threat agent. And then, of course, controls might be mandated from policies in an effort to reduce all possible vulnerabilities or threat scenarios that might occur. And controls usually either prevent the occurrence of the vulnerability, we update, we patch, we change the software, we stop using the software version that is vulnerable, the library, or we try to protect against a given threat scenario. We put a WAF in front of it, we put a some other kind of firewall, some other kind of protection, authentication, authorization. We try to detect, to respond, to recover. That's what we would be doing. So if we map some of the methodologies I pointed to in a couple of slides before, we will see that a threat scenario could be made up of Stride, Linden, and attack trees, and they don't really consider who the threat agent is. if you're using persona non grata security cards or Intel's threat agent library, they give you some capabilities, but they don't give you what exactly will be happening. But what about the vulnerability? How do we find the vulnerabilities? I mean, I was discussing this last week with a consultant trying to tell us to use threat modeling. And I was telling him, yeah, it's fantastic that you use Stride. Just if I use Stride as a brute force analysis tool or elicitation tool, and I talk to, and I have 20 elements, I have to go through all these and apply them, or I try to apply them to all 20 elements. And all these 20 elements in my graph, in my diagram, will give me 100 possible threats or threat scenarios. Which ones of these are valid? How much time do I have to waste on that? So something that I learned was very useful, and we'll talk about it right in a few slides, is the concept of the credible attack vector. So you have a threat agent, you have a threat scenario, and you have a vulnerability that is being exploited, and you are explicit about the vulnerability that is being exploited. This, of course, means that you might have at least some idea of what is going on in the system. So I'll switch to the next slide. So now we get to the meat of the presentation, right? So this is just stating some of the problems, and this is how to hack it to make it work. And the Open Security Summit without a Wardley map would be definitely too boring. So this is my attempt at creating a Wardley map of threat modeling. For those of you who do not know what Wardley mapping are, it's a method to analyze the components of a system or technologies that might evolve in time to see where you want to put your bets, right? It's trying to predict a little bit the future and take your strategical decisions based on something more than hocus pocus. So where I would say that the visibility ends from the consumer of your report is right after the report, right? So you will have a report which is created by the security architect or someone. This report will have two primary consumers, developers, system owners, and here with the system owners, we could put compliance officers, information security officers, you name it. You know your company better than I do. This group on the right-hand side is interested in risk. What is the risk? Can the system go live? This system on the left, these people on the left, these users on the left are interested in countermeasures. Now, if you have countermeasures coming from a report and risk coming from a report, you need a methodology to make sure that you get something of value, right? And the methodology will be giving you a few things. One is rating. How are you rating your scenarios? How are you rating your vulnerabilities? How are you rating risk coming out of it? Do you even have to rate risk? Or are you subject to the overhead of the risk management process on top of you? The methodology will also tell you how to track findings or the application of countermeasures. The methodology will also help you create threat models. And threat models, we basically need two big things. One is the modeling phase, the architectural diagram, and the other one is the threat scenarios themselves. Threat scenarios are built then, as I was showing in the previous diagram, by a threat agent who is capable of producing an exploit on an exposed vulnerability of the system. See, these are the three elements. If I look at automatic tools like the threat modeling tool from Microsoft, you will see that the threat modeling tool from Microsoft has no concept of a threat agent, has a concept of exploits being used, and it basically moves the head, allows this exploit finding to evolve a little bit to the right. The problem with that is it's extremely noisy because it is not necessarily considering the vulnerabilities. considering vulnerabilities it's a lot harder problem, I think. There might be some evolution here, but I'm not sure when or how that will be. And today, even in the non-evolved state, we can take a good library of threat agents is the threat agent library from Intel 2007, sorry. If you need exploits for different technologies, different systems, ICS, IT, Kubernetes, automotive even, there are attack matrices and KPEC from Mitre. If you need vulnerabilities, you might look at CWE, and something that I find often neglected when everyone talks about threat modeling is design principles. And architectural diagrams can also be based on the C4 model. And here is where I expect to be the most development in the future, because good diagrams that allow both the security team and the developing team, the product team, to work hand in hand and to keep them up to date, which are not cumbersome and which not involve changing the tools that you're using to create them, and which can be maintained as code, is probably where there will be a big barrier of acceptance, first of all, because some people are really in love with Visio, but Visio has challenges with creating only binary files or diagram files. And very often a person leaves the company and just leaves the PNG or the JPEG, but does not leave the Visio file. So it's impossible to update the diagram. I mean, raise your hand if you have never had to babysit a diagram that was created 1 or 2 years back and never updated because someone left the company and no one wants to do it. So a combination of automatic architectural diagram generation, which might be informed on vulnerabilities, I think that's where the future of threat modeling might be found, but I have no idea how complex that will be a challenge. But those are things that you can evolve even if there are no tools for it. These are things that you can evolve on your own. And let me walk you through that. So this is more of a personal story. I took over a course called Security in the Software Development Lifecycle. It was a whole day of training. And when I took the training as a trainer, not as a trainee, I took the training as a trainer, I had almost 1,000 slides. And it was a little bit of everything and nothing. It touched upon every possible thing in the world. So the first thing I did was get rid of a lot of things, and I tried to introduce threat modeling here. And somewhere in the company, in the department, someone was at RSA or Black Hat and had from Microsoft one deck of elevation of privilege playing cards. I didn't think much of it. I took them. I had heard about them, even seen a presentation by Shostak, I think. And I went to my training course. So I had colleagues from very different backgrounds. The only thing they had in common is none of them were security experts. But they were interested in how to do it right, which is the right attitude, right? So how do you cater to this group of people? How do you teach them the threat model? And the elevation of privilege cards are fantastic because they have a whole library of attacks that you can be using. But the problem is they would just take a card, read it out loud and say, I can see this happening. Yeah, but where, how? No one could pinpoint it because the elevation of privilege cards are looking exclusively at exploiting something that might be or might not be there. So it's great when you think of it, but if you haven't done the previous work of making sure that you have found vulnerabilities or potential vulnerabilities first, you will feel ridiculous. So the first challenge to to overcome is imposter syndrome. Then, once you have overcome that, and 50, 100, 200 people in your company have overcome that, how do you keep something close to reproducibility? How can you help most people find more or less the same things? Then we go into the topic of diagram quality. I was in a central position. I was in the central cybersecurity department, and many of the threat models that were created were collected, or part of the process was sending them to my team. And in my team, we looked at many of them, most of them probably, if not all of them. And we would see enormous quality differences in the diagrams. And one thing that we noticed very early on is automation tools. For example, the threat modeling tool from Microsoft. Oh God, they have a terrible signal to noise ratio. What is a signal to noise ratio? In this case, the signal could be true positives and a noise could be false positives. We had 400 items, out of which maybe 5 to 10 would be true positives. Find them in 400 findings. So that turned out to be a problem. So let's discuss how we tackled some of these problems. So let's talk about the first two, imposter syndrome and reproducibility. If I'm going too fast, please raise your hand, or if you have any questions so far, please let me know. I have the chat window open, and you can just interrupt anytime you want. So the first thing we should be happy about is that anyone can, and everyone should try to threat model. So we should get our developers to threat model. We should, or motivate them to threat model. I love Isar's Tarandanch's PyTM that tries to accomplish this. I like the agile threat modeling process as well, which is more of a checklist of things to do, but sometimes the checklist is just too long. And there's a lot of fear when you start. The first one, of course, is I will make a fool of myself. The second one turns out to be, what if I miss something? Followed by, very closely, maybe you can change the place, I have no idea what I'm doing. I had this feeling when I was teaching the first time, what am I doing? And then I realized it actually is flowing. And maybe the biggest blocker for many of my colleagues and myself was, okay, IT is changing the landscape enormously and incredibly fast. For many colleagues which come from a very classical 3D architecture, message queues, event-driven architectures, Kubernetes containers, some cloud services are really new territory. They have no idea where to start or get started. Once you look at the OT department, because we have factories in this company, then I had the privilege of trying out the first threat model for one of the production streets, they call them, production lines for one of the vehicle lines that was planned. And I had a collection of systems. I had no idea how they were working. And then I also had the privilege of being one of the first people in the company doing automotive threat modeling. The new vehicle that is hit the market just a few months back, I did the first analysis of it and its ecosystem back in 2015, I think. And you are faced with technology you have never heard of. Lean, flex rate, automotive Ethernet, I mean, can be a term, right? You can know it. But it's all embedded systems and they function differently, and can by default is an open, and same goes for Profibus. They are open protocols. Anyone can just join the network and start talking. And the only thing that matters is availability, then integrity, and last confidentiality, which is probably the opposite of what we expect in the IT world. In the IT world, we expect to have confidentiality, sometimes availability, sometimes integrity, and then the other one. And regarding reproducibility, everyone tends to do it a little bit differently. So how do we help everyone get up to speed? How do we help take these fears away? And one thing, the sound is a bit hazy. Okay, give me a second. Check. Oh, it's the. Is this better? I have been speaking to the condenser microphone, and apparently I was speaking to the wrong microphone. Is this better?
Yes.
Okay, thank you very much. Sorry about that. I didn't realize I was on the wrong microphone. So how do we solve the imposter syndrome? Methodology, checklists are a good thing to get started with. If we have a method to follow, if I have a series of steps, I can always orient myself. One thing that we need to keep in mind is my daughter yesterday got at the Chinese restaurant this cookie with this saying: there are many ways to climb the mountain, but the view is always the same. Which reminds me that there are different backgrounds, different perspectives, different starting points, but in the end, we want everyone to be enabled by a given methodology to be able to reach the top of the mountain. And even more important than that is, how do we provide a fail-safe environment to learn and practice? We solve this through training. We started with, I think, 2 days, well, 1 day. We then went to 3 days. We ended up with a whole week of training. Why? Because we had a lot of exercises. We had on-prem, we had cloud, we were even expanding into factory, shop floor systems and automotive systems. So who is your audience? What kind of systems do they face? Present them with scenarios that they feel comfortable and for which they can ask a lot of questions. Community of practice. Can people in different locations get together and discuss this? Because we had a company that was worldwide present. And something that worked very well, but took a lot of time and a lot of time every week from me and my team, and a lot of time to prepare sometimes, was the office hours. Every week we had a session. Every other week in the morning, every other week in the evening, in the afternoon. Why? Because we needed to be able to talk to the colleagues in Asia and with the colleagues in the Americas from Germany. And we were giving advice, we were providing input, and the community started to take off, and we started to identify threat modelers that really wanted to go beyond just doing the small things. And I think the methodology and the framework of methods is probably the best thing we achieved. So we tried to give different tools in the belt during the training. We had exercises with different approaches, and we avoided mandating a method for threat elicitation. What we wanted was the same documentation format. We wanted everyone to come to a threat model, to a credible attack vector, in whichever way they wanted to. Inspiration, experience, brute force, whatever they felt like doing. But that which was very important for us was that at least the community of system owners and information security officers could recognize the document that was being generated, and that the developers could take action on this. So one way to take the imposter syndrome away is to ask, is this thing that we're doing new? And for that, I find fascinating this document from 1970, the epoch, right? So the 1st of January 1970 is the epoch. This is 1 month later, 11th of February 1970. And if you read this statement,
probably the most serious risk in system software is incomplete design, in the sense that inadvertent loopholes exist in the protective barriers and have not been foreseen by the designers. You realize, even though we're, I don't know how many years ahead of this, almost 50 years, nothing has changed. We're still seeing the same problem, aren't we? And this is the first threat model I know of. So this is from the same document. And you will see that basically they identified with these gigantic computers that took up whole rooms. Look at the computer in comparison to the people. They identified basically STRIDE: information disclosure, active and passive elevation of privilege, authorization tampering, spoofing, you name it. So basically, there is nothing new under the sun. And even better, I find, are security principles. So if anyone from my previous company, I see one or two names there, you might recognize this because we were teaching them very often. Why were we insisting on this? Because these design principles allow us to identify violations that are always like a smell test. You pass by it, you immediately recognize that something is wrong. So these ones here are very old, 1975. Economy of mechanism, keep it easy, or keep it simple. Fail-safe defaults. Authorization decisions need to be taken by a central instance. Open design, which reminds a lot of Kerckhoffs's principle. The key is the secret, not the algorithm. Separation of privilege, least common mechanism, think environment variables, for example, and psychological acceptability, which is perhaps the hardest one. If we impose too much of a burden on our users, they will find a way around it. And more recently, I think, if I'm not correct with the date, please excuse me, I think it's either 2013 or 14, the IEEE published these design principles. Earn or give but never assume trust, authentication mechanism that cannot be bypassed, authorization after authentication, strictly separate data and control instructions, define an approach that ensures data is explicitly validated, use cryptography correctly, identify sensitive data and how it should be handled, consider the users. Number 8, understand how integrating external component changes your attack surface. Hello, JavaScript. Have I seen you before? Node.js, NPM packages? Wow. Be flexible when considering future changes to objects and actors. So having this makes threat elicitation a lot easier, because this is a very small list of things that can go wrong. But you can identify the OWASP top 10 here and more than that. So you could prevent probably all of the OWASP top 10 or most of it. I'm not sure about the newest version, the one that was published just 2 weeks ago, with these principles. And when I go back to the methodology, there is something that Brooke Schoenfeld created or coined as a term, which is the credible attack vector. And that is a credible threat exercising an exploit on an exposed vulnerability. So if we take it apart and look at it one by one, so who, with which capability, motivation, and risk appetite is how, which action to harm the asset, where does this active agent come in contact with the vulnerability? I think one of Brooke's favorite examples is, if I have to be root to exploit this vulnerability, I have bigger problems. Because if I am root, I will not exploit the vulnerability. I am already root, I own the machine, right? And then the vulnerability, what exactly is the system weakness that is being exploited? And what is the outcome? What does that mean for my system? So if we redraw it, the same diagram I presented just back, the threat just by existing is not necessarily a risk. it is the threat scenario that comes in contact with a vulnerability that increases my risk. And then the controls will try to prevent this. So this is the concept of the credible attack vector. And this is something that can help new practitioners and the recipients better understand what the problem is. And one thing that I found extremely important, because everyone was describing things in a different way, is to try to use Gherkin. So Gherkin is something that comes from behavior-driven development, if I'm not mistaken. And it is extremely logical, and it will probably be familiar to your developers. So Gherkin statements are built like this. Given preconditions, given this vulnerability exists and no control is in place, and the threat actor is doing, and the threat actor exists when threat scenario. Remember, what is the threat scenario? What action? So the preconditions, I have this vulnerability, I have this attack surface. Which action is this threat agent exploiting? And what is the outcome of it? So here are a couple of examples. So, for example, the vulnerability. There was no comprehensive input validation for strings, right? Which principle is being violated? Make sure that you separate data from code, and make sure that you validate all inputs. So two principles are being violated here. There is no input validation, and I describe what the vulnerability is. So we are not checking that it is within business limits. We're not taking that it belongs to an accept list, what we used to call white lists in the past. And that we're doing something with the string, right? And then the threat scenario using Gherkin is very easy to build, very easy to understand, very logical. Given the lack of input validation, when malicious input is sent to the backend, then outcome, the output will be used, or the input will be used. Maybe I made a typo there. And this can lead to several attacks from the OWASP top 10, including, or for example, all kinds of injection and cross-site scripting. Now, the same system exhibited these two other vulnerabilities. They were concatenating strings for SQL operations. So given string concatenation is being used, when user controlled input is used in the statements without filtering, and controlled instructions are mixed with data, then you have access to the database, or even worse, they were using dangerous functions without a sandbox. So they were using in Python eval and OS system, which basically means, dear operating system, could you please run this for me? So given these two functions are being used, and number one, no input validation is taking place, when malicious input is sent, an adversary can control execution of commands and take actions with the same level of access as other processes in the container. So if my container was running with root privileges, bam. So this helps a lot developers to understand what the problem is, and it helps to understand what the problem is, the vulnerability, but also how it can be exploited. So you are creating awareness while doing this. And then we come to the next challenge. Okay, so I was able to overcome my shyness, my imposter syndrome. How about everyone else in the company that was being taught by me? And when we started scaling throughout all locations, we started seeing that diagram quality was a topic. So I took from Microsoft's book, the software development lifecycle, the pet shop example. Very often, when I had an engagement for threat modeling, I got a diagram that looked like this. Name, maybe IP address, protocol, TCP, and port. Well, what can you say about this system? Nothing. I mean, we haven't passed layer 4 or layer 3 even. I have nothing to say about this system. What could go wrong? Everything, nothing. Now, a few pages later, they paint the same system like this. Now, I have lost the database server. Yes, I do see that anonymous users get a request, a response, and then maybe the pet shop customer, and then the admin. But where's my database? Or is the database part of the pet shop system? I mean, the difference here is not clear. So did I win anything by painting this in the threat modeling tool? And I would venture to say, no, you didn't win anything. Actually, you might have lost something. And I mean, TCP is by definition a request and response protocol. Do I really have to paint the response? What does it mean? Does the pet shop start by itself a connection to the pet shop customer? Or is it the TCP protocol just on the flowback? Do I really need this arrow on the bottom? And I found that many people did it, many people didn't. So it was really difficult. And then we have different problems, right? So one was correctness and reusability. So someone created this diagram using threat modeling tool, which of course is nothing developers use. Developers use something else, let's say Visio. So this diagram dies with the person who did the threat model. And since they only delivered the report, there's no way to update this. So the next security architect doing an update could have had to reproduce all of this again. So how do we keep it up to date? Who is keeping it up to date? And it's very messy. I mean, what is our target of evaluation here? Is it the left? Is it the right? Is it the bottom? Is it the top? Everything? And then we have the difference between abstraction and notation. And we spent a lot of time looking for alternatives to this. And I think the best alternative to this is the C4 model. The C4 model was created by Simon Brown. He's very active in YouTube and has a lot of presentations on the C4 model. So feel free to look at his website and look him up in YouTube and Twitter. He has great content on this topic. And what he basically created is an abstraction model that allows you to zoom in and out as if you were using Google Maps. So what I used to say to explain this to my colleagues was, this is the map of Europe. You see Germany in the context of its neighboring countries. You zoom in here and you see Germany in the context of the federal states that make up the country. And here you zoom in to a given city. And here you zoom into the location. And to be honest, we as architects don't need this. This should be created on demand by the developers. Components, unless it's really, really critical, I would advise not to go so deep. These two levels are probably enough for threat modeling. And I'll go into that, so no worries about that. So again, this is how Simon illustrates this. So he says, this is my system in the context of its users and dependent systems, Europe. This is my system in the context with some expanded functionality. So I now see inside of my system what is going on. And then I zoom in to see the Isle of Jersey with a lot more detail, and then inheritance classes when you take this road. Or put in a different way, which might be easier to look at, is I have my system, my users' dependent systems. I zoom into this system, and then I choose which systems or which containers from this system to zoom in into. And these are some of the principles of the C4 model that are really great, which I like a lot more than what is possible with the threat modeling tool. So you start with simple boxes, and the simple box has a name. It might have the technology or a description of it or the type of it, and it describes what it is supposed to be doing. And you put the most important thing, your target of evaluation, in the center. And you favor single directional lines showing dependencies or data flows. Of course, this is bi-directional. I mean, if you get the account, you will get information sent back, but this one is starting the communication, not the other way around. And if you need synchronous communication, then you can have a second line saying what exactly is the mainframe banking system doing to contact the internet banking system. And use an annotation to be explicit about the purpose of the line and the direction. And you know you did it right if you can read it as a sentence. The internet banking system gets account information from and makes payment using the mainframe banking system. So it's very easy to understand who is calling whom and which data is being retrieved. So the context diagram allows us to set our system in context: users, third-party systems, and relationships among them. Why does this system exist? What are these other systems doing with it? Then once you zoom in, right? So where do I want to zoom in? Here. Through the color coding, it's very easy to understand what is in scope and what is out of scope. I zoom in and I realize that I have a static web application that delivers a single page application to my machine, or a mobile app, and both of them are consuming an API in the backend. And this API, here we see the technology choices, we see what it does, reads data from a database and sends XML. This is probably an older system to the banking system. So far, so good. Any questions? And the beauty of this is you can create C4 diagrams with very simple tools. C4 diagrams are things that your developers also understand and which can be low maintenance. So you can start reusing between the security and the development teams, the same tools, the same diagrams. And one of the things that's great for me is it's easy to diff. You know what exactly changed between versions and you know who changed what. So for example, I have created with a very few lines of code. If there's any interest at the end of the presentation, I can show you the lines of code necessary to create this. I mean, this is very simple. I created the same pet shop thing, a customer which registers and creates appointments. I have a veterinarian which takes actions on the little animals, and I have my pet shop which is running in the Azure cloud. Now, this view has helped me talk to my developers a lot, because now I zoom in and I have my front-end single page application. My front-end single page application is calling an API. But actually, it is not necessary for this one to call the API. I can call it directly without this one. I just need the JSON web token and the URI. And this thing is executing in my environment. So usually I forgot to paint it here, but I usually do a second, excuse me. I usually paint a second zone around this to make it clear that even though they would like the single page application to be the one calling, it doesn't have to. And here I had the different components, and you see, it's easy to identify the technology choice, to understand what they're doing. And here I must say, for space reasons, I didn't put what these things were doing with each other. but that's something I usually do. And you can see here, I have the protocol authorization method being used. And that helps me identify potential vulnerabilities a lot better with a lot less noise. And developers are happy. Any questions, any comments? So this is the image I showed in the beginning. So you will see it's not very big. It's an IoT system, which will call an IoT update service, which has some firmware, and it is collecting some telemetric database, and there's a repair shop portal, and customers might make an appointment here to have the IoT device repaired. The repair employee will also be doing that. So not to make the story too long, this diagram had way more over 400 exploits or threat scenarios. And I'm not sure even 20 of those were fine. So the signal to noise ratio was horrible. So what do you do? To be honest, I stopped using this tool because one, it was very flaky. It crashed very often. Two, it was very difficult to maintain the diagrams. Yes, you get XML, but try diffing XML. And three, it's too noisy. So to close the presentation and allow some time for questions, and maybe if there's interest to show you how to create these diagrams very fast, I don't pretend to spend all the time doing this. Threat modeling is fun, but it is hard, especially in the beginning. So once you have been doing this for a long time, you forget how hard it is when you're starting. And the thing I realized is you need to let everyone start where they feel comfortable with. One thing that I've seen being a problem is mandating Stride in one of its flavors for threat elicitation. So when I was starting to do automotive threat models, the people who had the official responsibility for it said, we want to use Stride LM. And I'm like, okay, why do you want to use Stride LM? Because we read it was great. Okay, but have you used it? No. Have you experienced with it? No. Why are you mandating Stride LM? Try, fail, learn. Being agile is a lot about that. Good diagrams lead to better understanding of the system. It's easier to find vulnerabilities, and it's easier to understand possible threat agents present in different trust zones that might be able to attack different systems or subsystems within your complex system. If you can maintain diagrams as code, that helps everyone. You keep them close to the code. They are easy to maintain. Everyone is using the same tool. Developers don't have to leave the IDE, so there's no excuse for not doing it. And the diagrams can be built in the pipeline, so your documentation is always up to date. And perhaps the most important thing, if you forget everything I said, security principles are good. They are broadly applicable. They're not limited to one type of system, and they are great for getting very good signal to noise ratio, because you know that the threats that exploit these violations to these principles will probably be good. And credible attack vectors, if expressed as Gherkin, make everything be well understood. And if you are able to explain the problem, it is more probable that someone will feel the need to fix the problem. And with that, I am done with the presentation and ready for your questions. Thank you very much for being here. Anyone has a question? Well, I hope you're still there. So just to show you an example of a diagram as code. This diagram was was created in 40 lines of code, and most of it is HTML for the diagrams. HTML that can be, well, of course, I don't remember right now how to node. Well, I have created a series of shortcuts in Visual Studio code that allow me to create these tags very fast so that I can have them, and I can create them with Azure diagrams or AWS or any other source of PNGs that you might have. And the same I use for creating all the other diagrams I presented. So that's all I have to share for today. If there's any interest in having a session dedicated to creating diagrams as code, I could be very glad to have one session in the future, or in maybe doing a live threat model with a system, maybe the pet shop store using security principles and then threat elicitation. I would also be happy to do that. So thank you very much for being here.
Thank you very much, Luis. Have a nice evening.